Hello, I'm Priyansh and today it's time to discuss about one of the ways from which our universe can be destroyed. Vacuum decay. So, what is vacuum? You must be thinking what a ridiculous question I'm asking. What is vacuum? It is something that has nothing. Even though it's a great topic to talk about, in this video we are not talking about vacuum of space. Instead, we are talking about vacuum of state. Let me explain this. The universe is best described by quantum field theories. Quantum field theory tells us that the universe is fundamentally made up of quantum fields. A field is something that has some value in every point of space. You can visualize this that it's present everywhere like a fluid, and everywhere it is, there is a value of this field. So what are particles? The particles appear, or the particles are the excitations of their corresponding quantum fields. Or you can say that the place where the energy of their respective quantum fields are higher, they appear. For example, electrons appear where the energy of the electron field is slightly greater, or the excitation of the electron field. Same way, every known quantum particle has a corresponding quantum field. By the way, antiparticles appear where the value of the electron field is lower, or the negative excitation. The lowest energy state of a quantum field is known as its vacuum state. The decay of any quantum field to a more lower energy state is called a vacuum decay. It happens because quantum fields, so as anything in the universe, wants to be at its lowest energy state, the vacuum state. But our current vacuum state of the universe do not appear to have reached its lowest energy state. It has got stuck in a local minimum of energy, which means that it appears to be minimum to field, but there is a global minimum of energy into which the vacuum can decay into. Our universe is in a false vacuum. That means it is in a vacuum that is not entirely stable and got stuck in a local minimum of energy. This type of vacuum state is called a metastable vacuum state because it is not currently decaying but contains a huge amount of energy and can start decaying anytime. Whereas the true vacuum is a vacuum which has reached its global minimum of energy. For analogy, think of a river that has been stopped by a dam. The river wants to destroy the dam and came down to its lowest energy state, the sea level. But to do that, it needs to cross the potential barrier of the dam, or in other words, needs energy to destroy the dam. If it gets that much energy to destroy the dam, it will eventually destroy the dam and came down to its lowest energy state, the sea level. Here, the river is the quantum field. The river before the destroying the dam was in a false vacuum, or the local minimum of energy, and after destroying the dam, it came down to its lowest energy state, the true vacuum, or the global minimum of energy. Why is the current vacuum state metastable? Because the vacuum instability criteria for the electroweak interaction is dependent upon the masses of the Higgs boson and the heaviest fermion, the top quark. The top quark is discovered in 1995 and the Higgs boson in 2012 in the Large Hadron Collider in Geneva, Switzerland. So since 2012, by analyzing the masses of these particles, the best prediction which we have is that the mass of the Higgs boson lies in the regime that predicts the current vacuum state of the electroweak interaction to be a false vacuum. That means there is a lower energy vacuum state available to which the electroweak vacuum can decay into. This process is known as electroweak vacuum instability or Higgs vacuum instability. How could the vacuum can decay? The process of false vacuum to decay into true vacuum is known as bubble nucleation. There are some ways from which false vacuum can decay into true vacuum. Two of them are: first, if we create a high enough energy event, in theory we can push a tiny region of space from false vacuum to true vacuum. But the energy required is too large, because if it wouldn't, the universe is filled with high energy events such as supernovae, black hole mergers, neutron star mergers. So you can think of it like that we need a large amount of energy to do that. The second way is that in quantum mechanics there is a process called quantum tunneling, in which a particle can cross a potential barrier without having enough energy to cross that barrier. It can do that because the particle's position in quantum mechanics is described by wave function squared. Its wave functions squared, and the probability is non-zero outside the barrier also, and hence it can tunnel sometime through the barrier and can get outside of the barrier. Same way, False vacuum can also turn into true vacuum by this quantum process. How likely is a vacuum decay? With current understanding of physics, the lifetime of a metastable vacuum is about 10 to the 600 times the current age of the universe. It is ridiculously large. That means we have other things to worry about. What would happen if the vacuum did decays? After vacuum decays in the region of space-time, the bubble of true vacuum would be formed with high energy walls and it would expand at the speed of light. And it would expand at the speed of light signifies that we will not know the vacuum is decayed until it has been decayed. The walls would release an enormous amount of energy trapped in the false vacuum. The true vacuum has different sets of constant and different rules of the universe. For all we know is that the universe as we know it would not exist and we all will die a painless death. At last, one thing that I have to clarify you is that it is the prediction of an incomplete physics applied in an untestable regime of energy. But the conclusion is that everything has an end and the universe has no exception. Maybe it will not die with vacuum decay, but maybe it would be heat death or the big rip or the big crunch or maybe rebuild itself in the big bounce. But for all we know is that we have a lot of time. Thanks for watching this video. See you next time. Thank you.